Hey guys, so I'm gonna show you how I did Advent of Code, day one, 2024 in C++. So first, let's go over the problem. So we're given two lists side by side, and they have like a little story with it. But reality, it's just two lists, right? And now we need to basically find the difference between two numbers and then add up all those differences. So for this example, we need to find the smallest number in the left list and the smallest number in the right list, and then find the difference between them. This one we have one and a three, so it's gonna be two. For a sec, and now then we need to find the second smallest number. So that would be two in the left list, and the second smallest number in the right list would be three. Difference between them is one. Third smallest number in the list is three, so it's just gonna be three minus three, right? So the distance between them is zero. Next one, the next number is gonna be three and four, distance of one, and three and five, two. Finally, it's gonna be four and nine, which is five. Now, don't get fooled because at the start, I thought on the right side it would always be the biggest one, on the left side would always be the smallest one. That would not be the case because for this, it showed that okay, let's say we have uh three a three and a seven, so three on the left side and seven on the right side, it's going to be four, right? But then it shows here nine on the left side and three on the right side, and it'd be six. So basically, we need to find the maximum value between the two and the minimum value between the two, and basically minus them by that. So let's do it. So I already have the all the numbers right here. It's like 2,000 numbers because 1,000 times two. It's a lot of numbers, right? So let's do this. First, I'm gonna have if stream and so we can read in those numbers. Call it ifile, and I'm gonna immediately open it. So input txt. Then I'm gonna have placeholders for it. So left num, yeah, left num. I'm gonna make a negative one for now, and then right num equal negative one for now as well. And now I have a vector for both. So vector int, I'm gonna have left side and then right side. So it's gonna be like the left side of the numbers and the right side of numbers. So now all I need to do now is just read in the numbers, put them in the vectors, and then from there we'll figure out the rest of it. So I'm gonna have a while loop. I could do a for loop and just do it 1,000 times, but we'll just do a while loop because it's nicer. So while ifile keeps putting a number into left num and also right num, all we're gonna do is just do left side push back left num and also right side dot push underscore back right num. Okay, and now we'll basically just get all the numbers in, and let's go check if I did that right real quick. So I'll just have like a cout statement right here. I'll put my debugger onto here, and let's see what happens. The last number should be, let's see, fit 45,000. Let's check out if it's 45,000 on the right side vector. Hopefully it is. Nice, it is. Let's check out the left side just in case. 53,000. 53,000. Nice. Okay, it is. So that's good. So let's keep coding. So now that we got all these numbers, now we need to figure out like smallest number, smallest number, smallest number. The immediate thing I thought was just sort it, right? We could do a heap and keep pushing back into our heap and then keep popping from heap and we'll basically do like a min heap, but that's like doing too much, I'd say. And this is not leak code. We're just like trying to find out the number, right? So all we're gonna do is just sort left side dot begin and left side dot end. And then basically the same thing, right? Sort right side dot begin and then right side dot end. And now basically they're sorted, right? From smallest to largest. And now from there we can figure out uh the smallest like the nth smallest number of the left side and the nth smallest number of the right side, right? So now all we can do is just do a for loop, right? From I equals zero, I is less than you just do left side dot length. I mean they're the same, they should be the same size, hopefully. Oh, not size, my bad. And I plus plus, right? And now, as said earlier, we need to here, let me bring it up. We need to figure out like which one's the biggest one and which one's the smallest one from left to right. And what we can do is use a function from the algorithm library called maximin, which basically gives us the like the largest number between two sides. and min will do the smallest number between two sides, meaning like the two parameters that we give it. So for example, actually we need to let's have an int distances equals 0 because it says here that we have to add up all the distances from all the numbers. So we got the two, we got the what is it, the one, the 0, the 2, the 5, and we're gonna add up all of them. Oh, I forgot one of the numbers, but we just add up all of them and we'll get it. And then if you try to use my answer again, it's not. It's pretty sure it's different for everyone, but we should come up with this answer right here. So int distance equals 0. So we're gonna say distances plus equals. So we're gonna find the max between left side at I and the right side at I, and we're gonna minus it by the min of again left side at I and then the right side at I. So let's think about all like the test cases we could have. So let's say the left side's the smaller one, the right side's a bigger one. So then this would get us the right side, right? And this will get us the left side because left side's smaller, right side's smaller. Then again, let's say the left side is bigger, the right side's smaller. Then again, left side's gonna max is gonna return the left side, min's gonna return the right side. Last test case is what if they're equal? Well, it doesn't matter. So it doesn't matter if it gives us left side or right side. It doesn't matter if they give us left side or right side because they're equal. So it's just gonna be 0. Mm. And just to be cool, why don't we just like delete the brackets? There's some cool points, I guess. That should be it. So if you see how distance is right now, see what happens. So G plus plus, CPP, and that's actually 2742123, 2742123. Nice. Okay. So for Advent code, there's always a part one, part two. So let's check out part two. So figure out that I guess the historians found out it's wrong. So what we need to do is calculate a total similarity score. So let's check it out again. So for this example, first number in the left list is 3. So it appears in the right list 3 times. So what we need to do is 3 times 3. So we need to add the 9 to like our summing thing. Second number 4, it appears only once on the left side. So we do 4 times 1. So it's 4. We add it up. Third number, left list is 2, so it never appears on the right side. So the score does not increase at all. Okay. So we need to take care of that case. So fourth number is 1, also does not appear in the right list. So the fifth number, 3, appears in the right list 3 times, so we do 3 times 3 again, right? And then the last number, 3, appears in the right list 3 times. The similarity score, again, increases by 9. Okay, so we can see that we don't really need to sort it anymore, right? All we're doing is just putting it into, let's say, vector or maybe a map, right? And all we're doing is just gonna be like oven. So it's just gonna be oven adding them to the vectors, and it's gonna be oven going through like basically this right here and trying to find out how many times does it appear on the right side, right? So let's do it. So that's why I have the unordered map here. So we don't really need, okay, we do need left num, we do need right num. We don't really need right side as a vector anymore, but we do need it as like an ordered map. So of int and then int. So basically the first one's gonna be int, like the number, and the second one, okay, wait, what was it called? The key is gonna be like the actual number. The value is gonna be how many times does it appear on the right side. So we're gonna call it right side occurrences. It's gonna call it OCC. So while it puts it, we're just gonna say this. I'm gonna say, uh, hmm, we need to take care of the case of like, what if it doesn't appear in the right side? We need to do 2 times 0. But if we were to try that, I'm pretty sure if we try to find it in the map, it's gonna segfault because we haven't put it in the map yet. So what we need to do is, uh, so left side that pushback left num. Okay, so if maybe this is redundant, maybe, but I'm just gonna keep trying to do this. So if right side the current dot find right num, actually no. I think this is doing too much. We can just say this. So right side occurrences at right num. plus plus. So what this will do, it will go to that value in the map and add it by one. It's default by zero. So like let's say the value, maybe you're saying like, okay, well if it's initialized, it's okay because it defaults by zero. So let's say maybe we can go to input to check it out. But just know that it will go to this value in the map. It will make a new one. It will default by zero. Then the plus plus will add it to one. So for example, like for the four, actually let's do for three, right? It will make a value. It will make a spot for three. Then the key, I mean, the key three, it will make a spot for it. And the value will be defaulted by zero at the start, but then the plus plus will make it a one. So then over here, it will go to that spot again, make that one to a two. It will go to that spot again over here. It will make that spot from the two to a three. That's what it's basically doing. And then I guess when we try to do like let's say the value is not there, we'll do if dot find equals dot end. Basically, if it's not there, it'll like return like dot end. We'll just continue because we don't really care about that value. So we don't need to sort anymore. So we don't care about that. And we'll call this, what did they call it? They called it uh, similarity. So we'll just call it similarity here too. So similarity equals zero, right? So again, say similarity. So that's the end of it, right? So right here, all we're gonna do is this. So if right side occurring dot find left side, right? If it finds it, oh, at I, my bad. If it finds this number, if this number, right, does not equal right side occurrences dot end. So basically saying if this number is in the map, okay, then we'll do similarity plus equals, hopefully I'm doing this right, left side at I times right side occurrences at left side at I. And then let's see. So let's understand this real quick. So let's just go. Let's do this. Hold on, let me do it side by. Let's do it side by side, right? So all these numbers on the left side are currently in left side. So we got 3, 4, 2, 1, 3, 3, right? And in the map, we have like 4 being the key, and it's gonna looks like it's only one value, right? And its value is 1. 3 being the key, and its value is gonna be 3. 5 is being the value, and it's only 1. 9 is a key. 5 is a key, my bad, and 1 is its value. 9 is a key, and its value is a 1, right? Because that's how many times it's in the right side. So we're going through this one, right? 3. So if right side that occurrence the 3, we're trying to find the 3. If it's in the map, it won't return right side. This won't equal right side dot end, right? So that means it's in the map. So we'll do similarity plus equals left side, so 3, and right side occurrence is like, so how many times is it there? So 1, 2, 3, so 3 times 3 is 9. 4 right here. So we try to find it. Is it in the map? It is. And how many times is it occurring? 1. So it's gonna do 4 times 1, it's gonna add its similarity. 2 though, it's not in the right side. So therefore it's not gonna be even in the map. So this if statement won't be true. So that means it will return dot end. So hopefully I'm right. Hopefully what I just said was right. Here, let's do this. Let's do the G plus plus. Actually, we're gonna do this like this. Find out it's 213-284-97. 213-284-97. Boom. That's day one of Advent Code. Hopefully this way of doing it made sense. Found out that there's a leaderboard for the people who get it first. I don't really care about that. I think I care. All I care about is just like if I get it. So yeah, hopefully you guys found this helpful, and yeah.